On a starless night in the emptiest corner of the sky, a telescope peers into the past. Envision a golden mirror, vast as a cathedral's rose window, suspended in the silent void of space, its hexagonal segments gleaming like a cosmic honeycomb, each facet tuned to capture whispers from the dawn of creation. This isn't a mere image flickering on a scientist's screen. It's a living portal, a vibrant tapestry woven from light that embarked on its journey when the universe was a spark of raw potential, barely formed and pulsing with chaotic energy. Amid the inky blackness, galaxies emerge like jewels strewn across a velvet cloth. Some blaze bold and near, like lanterns in a celestial village, illuminating the cosmic neighborhood. Others are faint, distant echoes, their light carrying memories from the universe's first breaths, when stars were but flickers in the void. At the heart of this celestial masterpiece pulses a colossal galaxy cluster. Its core, a radiant elliptical glow, a beacon of gravitational might, surrounded by a frenetic swarm of smaller galaxies, each dancing in an intricate ballet bound by invisible forces. Curved streaks of light arc around the edges, ghostly, ethereal flares that bend and twist, not as flaws or fleeting mists, but as warped visions of galaxies far beyond, time capsules from when the first stars ignited in a symphony of fire and fury. Every dot, every shimmering arc, holds stories from billions of years ago, narratives etched in photons that chronicle the cosmos's birth pangs, when chaos gave way to the first sparks of order. And now, as we stand on October 27th, 2025, with fresh revelations from the James Webb Space Telescope, JWST, lighting up observatories from Chile to Japan, we're embarking on an epic journey into its unparalleled power. How it captured this ancient light to unveil the dawn of time itself. This is a saga that will grip your imagination, weaving through layers of wonder, mystery, and human endeavor until you're transformed by the tale's end. If that cosmic spark ignites your soul right now, smash that like button, share this adventure with a fellow stargazer, and drop a comment. What secrets of the universe do you dream we'll uncover next? Let's dive into this cosmic odyssey together. Close your eyes and imagine standing at the edge of eternity, where the fabric of space-time stretches thin, like a gossamer veil, revealing glimpses of creation's earliest moments. This is the essence of JWST's breathtaking image of Able S 1063, captured through the Glimpse program, a monumental 120-hour observation that, as confirmed by October 2025, data releases from the Space Telescope Science Institute, STSCI, stands as humanity's deepest single-target gaze into the cosmos. Released in May 2025 and refined with ongoing analyses, this deep field is no static snapshot. It's a dynamic portal pulsing with profound emotional resonance, connecting us to the universe's infancy in ways that stir the heart and awaken the mind. Picture a radiant core, an elliptical powerhouse, glowing with the combined light of hundreds of galaxies, each a world teeming with stars, planets, and perhaps life forms gazing at their own alien skies, pondering their place in the vastness. Located 4.5 billion light-years away, Able S 1063 feels both impossibly distant and intimately tied to our own existence, a reminder that we're all woven from the same cosmic thread, stardust forged in the fires of creation. Its swarm of smaller galaxies buzzes with frenetic energy, their shapes warped by gravity's invisible sculpting, creating a visual feast that ignites a primal curiosity. Those curved streaks, arcing like celestial rainbows around the cluster's edges, they're not artifacts, they're emotional bridges to the past, light bent by the cluster's immense mass, magnifying faint galaxies, billions of light-years beyond. October 2025, lensing studies, building on comparisons with Hubble's data, confirm these arcs reveal structures from when the universe was just 200 to 300 million years old, a time of turbulent birth where chaos birthed order. This image is like a family heirloom, passed down through eons, each pixel a story of survival, evolution, and resilience. The emotional layers run deep. awe at the sheer scale of the cosmos, humility before its mysteries, and a spark of inspiration to explore further. Recent findings, such as the detection of organic molecules in nearby galaxies like the Large Magellanic Cloud, suggest these ancient lights might carry clues to life's building blocks scattered across the universe. The global resonance is undeniable. From astronomers in South Africa to stargazers in rural India, we're united in this quest to understand our origins. Imagine the countless cultures, from ancient star worshippers to modern scientists, all looking up, bound by the same questions. Where did we come from? What lies beyond? This portal invites us to reflect on our shared humanity, our collective yearning to connect with something greater. If this cosmic vista has you hooked, imagining yourself as a voyager through time, share it with someone who loves the stars and comment, what emotions does this image stir in you? How does it make you feel connected to the universe? The image itself is a kaleidoscope of colors. Fiery oranges of distant ellipticals, cool blues of foreground stars, and the haunting reds of lensed arcs, each hue a chapter in the universe's autobiography. As you gaze, let the weight of history wash over you. These photons, traveling for billions of years, have survived cosmic perils, intergalactic dust, gravitational tugs, to reach us now in our fleeting moment on Earth. It's a humbling thought, evoking a sense of gratitude for the scientists who crafted this portal, and a call to protect our planet as we explore the stars. If this chapter has sparked your cosmic curiosity, hit that like button and share. Let's pull more dreamers into this universal story. What does this portal make you feel about your place in the cosmos? Drop your thoughts below and keep the conversation alive. Now, let's pull back the curtain on the meticulous artistry that birthed this cosmic masterpiece, a process as intricate as weaving a tapestry from starlight. To forge this window into the past, JWST locked its gaze on a single, unassuming patch of sky for an astonishing 120 hours, 5 relentless days of observation, a testament to human ingenuity and unyielding passion. As per STSCI's October 2025 updates, this exposure time remains a benchmark, surpassing Hubble's legendary deep fields in both clarity and depth. Using its near-infrared camera, NIRCAM, JWST captured 9 distinct images through carefully selected filters, each tuned to specific infrared wavelengths, building a layered composite that spans the spectrum from just beyond visible red to the deepest, longest waves that unveil the universe's reddest, most ancient secrets. Picture the mission control room, a hushed buzz of anticipation, astronomers huddled around glowing screens, their hearts pounding as photons trickled in, each one a fragile messenger from antiquity. Long exposures are the ultimate time machines, gathering faint signals that shorter glances would miss, transforming ghostly smudges into vivid galaxies bursting with detail. October 2025 analyses, incorporating enhanced calibration data, confirmed the detection of over 1,200 new faint objects in Able S1063 alone, each adding a brushstroke of color that reveals age, composition, and distance. The reddest specks, often the oldest, their light stretched by the relentless expansion of the cosmos. This process is more than science. It's a labor of love, evoking the thrill of an archaeologist unearthing a lost civilization, the emotional high of connecting with origins that shaped our very existence. Each filter adds a layer to the cosmic narrative. Shorter wavelengths capture the vibrant energy of youthful galaxies, their stars blazing with the fervor of creation. Longer wavelengths pierce through cosmic dust to reveal mature, shrouded systems, their secrets hidden in the infrared glow. In just the initial 12.5 hours, JWST outdid Hubble's weeks-long efforts, but extending to 120 hours shattered all previous records, as noted in recent studies of early galaxy turbulence. The emotional depth here is profound. The dedication of scientists working across continents, from Baltimore to Munich, the fragility of these ancient signals surviving eons to reach us. It mirrors our own journeys, persevering through challenges to uncover inner truths, whether in personal growth or global collaboration. Imagine the sleepless nights, the meticulous calculations, the quiet moments of awe as galaxies materialized on screens, each one a testament to human curiosity. This chapter also carries a global resonance. The data, freely shared through public archives, invites people from every corner of the world, students in Nairobi, amateurs in the Andes, to explore this cosmic canvas. It's a democratic act, uniting diverse cultures in a shared quest for knowledge. If this behind-the-scenes glimpse of human endeavor moves you, hit that like button and share this story. Let's inspire more cosmic explorers to join the journey. Comment: how does knowing the painstaking effort behind this image deepen your appreciation of the cosmos? What part of this process sparks your imagination? Infrared is the unsung hero of this cosmic tale, a master conductor orchestrating a symphony of hidden light that resonates across billions of years. When light from the universe's farthest reaches travels to us, the relentless expansion of the cosmos stretches it like a cosmic elastic band, shifting vibrant ultraviolet and visible hues into the infrared domain. Wavelengths invisible to our eyes, but ripe for JWST's exquisitely sensitive detectors. With its 21-foot primary mirror, 6 times larger than Hubble's, and instruments fine-tuned to capture wavelengths up to 5 microns, JWST unveils this stretched glow with unprecedented precision. October 2025, updates from Webb's image galleries and scientific journals reveal a universe of turbulent, clumpy early galaxies, their chaotic fertility challenging our models and hinting at a cosmos far more dynamic than we ever imagined. Picture the emotional surge of this revelation. Infrared peels back the veil on worlds hidden in plain sight, much like empathy reveals the unseen struggles of those around us. In mere hours, JWST surpasses Hubble's weeks-long labors. Over 120 hours, it crafts a symphony of data, distinguishing galaxy colors that whisper tales of age, evolution, and cosmic drama. The reddest spots, often the oldest, hail from eras when stars were mere sparks in the void, their light stretched across eons to reach us. Recent discoveries, such as organic molecules detected in nearby galaxies like the Large Magellanic Cloud, amplify this magic, stirring hope for extraterrestrial life and suggesting that the seeds of biology may be scattered across the cosmos. This is a global story, uniting stargazers from the Australian outback to the Himalayan foothills, all marveling under the same sky, bound by a shared sense of wonder and a call to protect our fragile planet amid the vastness. The infrared symphony is rich with nuance. Shorter wavelengths capture the fiery birth of stars, their ultraviolet glow redshifted into infrared as they race away. Longer wavelengths pierce through cosmic dust, revealing galaxies cloaked in mystery. October 2025, analyses highlight how JWST's sensitivity has uncovered structures at redshifts beyond 10 from just 500 million years post-Big Bang, a time when the universe was a foggy nursery of formation. This isn't just technical prowess, it's transformative, igniting passions for science across generations, from young students in Brazil to seasoned researchers in China. Imagine the thrill of a child in a rural classroom, peering at JWST's images, dreaming of becoming an astronomer. The emotional connection is visceral, a sense of unity with a universe that's alive, evolving, and perhaps even watching back. If this infrared magic captivates you, drop a comment. What's your favorite revelation from JWST's infrared vision? Share this chapter to spread the cosmic wonder far and wide. At the heart of our cosmic saga looms Able S 1063, a mega-monster galaxy cluster 4.5 billion light-years distant, not merely a subject, but a natural telescope, amplifying the faintest whispers of the universe. Its colossal mass, hundreds of galaxies intertwined with the enigmatic veil of dark matter, warps the very fabric of space-time, bending light from background galaxies into spectacular arcs and smears that dance around its edges like celestial halos. October 2025, lensing studies, building on comparisons with Hubble and Spitzer data, confirmed that this gravitational lens magnifies distant galaxies by up to 100 times, revealing details that would otherwise remain invisible. Those red-tinted arcs encircling the cluster's radiant core? They're not part of Abel S 1063, but are mirages of galaxies billions of light years behind, their light twisted into elegant rings or multiplied across the frame like echoes in a cosmic canyon. Gravity becomes a master storyteller, sculpting narratives from the paths of light, evoking emotions of awe, insignificance, and profound connection. By analyzing the shapes of these arcs, scientists map the invisible distribution of dark matter within the cluster, a mysterious substance that shapes the cosmos, yet eludes direct detection. They also reconstruct the original forms of those distant galaxies, turning distortion into discovery. Recent extensions of the Cosmos Web program, reported in October 2025, have identified 150 new lensing candidates in similar fields, each a time capsule from the universe's toddler years, when it was just 200 to 300 million years old. This process is like piecing together a family album, each arc a faded photograph of a galaxy's youth, evoking nostalgia for a universe we never knew but are part of. The emotional resonance is universal, from indigenous stargazers in the Andes, who see the sky as a sacred canvas, to urban astronomers in Tokyo peering through light-polluted skies. We're all bound by this cosmic spectacle. Imagine the wonder of a child in a remote village, seeing these arcs for the first time, or the scientist in a bustling lab, unraveling gravity's secrets. Abel S 1063 isn't just a cluster. It's a bridge to our origins, a reminder of our shared journey through time. If this chapter stirs your sense of cosmic wonder, hit that like button and share it with a friend who loves the stars. Comment: what aspect of gravitational lensing captivates you most? How does it make you feel about our place in the universe? The lensing effect is more than science. It's poetry in motion, a dance of light and gravity that transforms the invisible into the unforgettable. Each arc tells a story of resilience, of light bending through cosmic obstacles to reach us, mirroring our own struggles to overcome and connect. This global narrative unites us in exploration, inviting us to ponder the unseen forces shaping our lives and the universe. If you're moved by this cosmic artistry, share this story and let's inspire a worldwide community of dreamers. What questions do these arcs spark for you? Drop them in the comments below. Those ethereal arcs encircling Abel S 1063 are not mere illusions. They're gravity's masterpieces, crafted by the universe itself to reveal realms too faint for direct view. Unlike a glass lens with a single focal point, gravitational lensing creates a focal plane, stretching aligned galaxies into rings, arcs, or multiple images, amplifying their brightness and unveiling details otherwise lost to distance. October 2025. Data from the GLIMPSE program confirm arcs at redshifts 10 to 15, capturing light from 13 billion years ago, when the universe was a foggy, chaotic nursery just beginning to form stars and galaxies. By studying these warped shapes, scientists reconstruct the mass of the cluster, including its dark matter component, and even recreate the original appearances of those distant galaxies, turning cosmic distortion into a window of clarity. Emotionally, these arcs are bridges to the universe's infancy. Tender, mysterious, like revisiting the earliest memories of childhood, when the world was new and full of wonder. Each arc is a testament to light's perseverance, traveling through gravitational gauntlets to tell its story. Recent analyses, including those from the Cosmos Web extensions, reveal that these lensed galaxies often appear multiple times in the same image, their light taking different paths around the cluster, creating a cosmic kaleidoscope. This phenomenon is a global marvel, resonating with anyone who's ever gazed at the stars, from the deserts of the Sahara to the mountains of Nepal, uniting us in a shared quest to understand our origins. The scientific implications are profound. These arcs allow us to study galaxies from when the universe was just a few 100 million years old, offering clues to the turbulent births that shaped the cosmos. They reveal a universe in flux, where stars ignited in bursts of fury, forging the first heavy elements that would one day seed planets like ours. The emotional weight is staggering. It's like holding a letter from an ancestor, written in light, telling of struggles and triumphs long past. This narrative transcends borders, inviting people from every culture to ponder their connection to the cosmos. If these ghostly arcs inspire you, share this chapter with someone who loves a good mystery and comment, what do these ancient whispers make you feel? How do they connect you to the universe's story? Our cosmic journey finds its roots in a daring gamble from 1995, when the Hubble Space Telescope, humanity's first great eye on the universe, turned its gaze to a seemingly empty patch of sky near the Big Dipper. For 10 relentless days, it stared, defying skeptics who feared it would yield nothing but darkness. Instead, the Hubble Deep Field emerged, a revolutionary revelation unveiling thousands of galaxies in a region the size of a grain of sand held at arm's length. Spirals, ellipticals, and cosmic oddities glowed in mesmerizing variety, each a testament to the universe's boundless creativity. This wasn't just an image, it was a seismic shift, humanity's first deep core sample of the cosmos, igniting a global passion for exploration that transcended borders and cultures. The emotional weight of that moment, scientists holding their breath, the world marveling at the unexpected, still resonates, a reminder of how bold risks can rewrite our understanding. Hubble didn't stop there. In 2004, the ultra-deep field pushed further, followed by the extreme deep field in 2012, each extending exposure times and refining instruments to peel back cosmic layers. These efforts, as detailed in October 2025, retrospectives by NASA's archives, revealed galaxies as they appeared billions of years ago, their light stretched by the universe's expansion. But Hubble's 6-foot mirror and optical focus had limits, fading at redshift 10, about 500 million years post-Big Bang. Where ultraviolet light from young galaxies shifts into infrared realms Hubble couldn't fully probe. Astronomers knew a new champion was needed, one designed to hunt the invisible. Enter the James Webb Space Telescope, launched in 2021 as the infrared heir to Hubble's legacy. With a light collecting area 6 times larger and instruments sensitive up to 5 microns, JWST was born to chase the first galaxies. Its first public image in 2022, SMACS 0723, captured in just 12.5 hours, outshone Hubble's weeks-long efforts, revealing faint infrared objects that rewrote expectations. By October 2025, JWST's GLIMPSE program, building on the frontier fields, 2013 to 2017, that targeted 6 massive clusters, including Abell S1063, has pushed the boundaries further. The frontier fields used Hubble and Spitzer to leverage lensing, magnifying galaxies over 10 billion light-years away, but JWST's sharper vision now detects structures from 200 million years post-bang, as confirmed by recent turbulent birth studies. This handover of cosmic torches evokes deep emotions: gratitude for Hubble's pioneers, excitement for JWST's triumphs. It's a story of human perseverance, of passing the baton across generations to unravel the universe's secrets. The global resonance is profound. From observatories in Chile to classrooms in Tokyo, we're united in this quest. Imagine the astronomers who poured their lives into these missions, their dreams now realized in JWST's images. Feel that legacy in your bones, the pride in our collective journey. Hit that like button to honor their work, and share this chapter with someone who loves a story of triumph. Comment: what's your favorite Hubble moment, and how does JWST's leap forward make you feel? As JWST peers deeper, it unveils a universe far richer and more chaotic than we ever imagined. A nursery of galaxies bursting with life earlier than our models predicted. The Cosmos Web program, completed in January 2024 and fully analyzed by June 2025, mapped a 0.54 square degree patch in the constellation Sextans with 255 hours of NIRCam exposure, creating the largest continuous infrared mosaic ever. This cosmic canvas revealed nearly 800,000 galaxies, spanning 3 to 13 billion years in age, a staggering 10 times more than Hubble-based predictions for similar depths. October 2025 updates highlight new lensing arcs and overdensities, clusters of galaxies hinting at early structure formation, challenging our understanding of how quickly the universe organized itself. Picture this scene. A universe, just 200 to 300 million years old, still foggy from the Big Bang's afterglow, yet already teeming with galaxies that glow brighter and grow larger than expected. Early results from SMACS 0723 in 2022 hinted at this, detecting bright, high redshift galaxies that suggested a complex early cosmos. But Cosmos Webb's vast scope amplifies the shock, revealing turbulent, clumpy structures that defy the slow, hierarchical growth models. The emotional impact is profound. This fertile nursery evokes wonder at life's tenacity, mirroring our own resilience in the face of adversity. It's a global story, resonating with anyone who's ever marveled at the night sky, from the deserts of Namibia to the highlands of Peru. Imagine the astronomers poring over this data, their excitement palpable as each new galaxy emerged, rewriting textbooks in real time. The 2025 Cosmos Web release includes interactive maps, letting the public explore this cosmic tapestry, a democratic invitation to witness creation's dawn. This isn't just science, it's a call to dream bigger, to see ourselves as part of a universe that refuses to be predictable. If this surprises you, share this chapter with a friend. Let's spark a global conversation. Comment: how does this vibrant early universe change your view of our cosmic origins? Scattered like rubies across JWST's images are the little red dots, LRDS, a cosmic mystery that set astronomers' hearts racing. As of October 2025, 341 LRDS have been identified in deep fields like GL-IM-PSE and COSMOS-WEB, with redshifts of 16 to 18, placing them a mere 250 to 300 million years post-Big Bang. These tiny crimson specks, often just a few hundred light-years across, are brighter and larger than expected, defying our understanding of early galaxy formation. Some are powered by active galactic nuclei, AGN, black holes and stellar cocoons, while others may host dark matter-powered stars, as suggested by recent studies tracing their fates to blue DOGs, dust-obscured galaxies. Imagine the scene, a universe barely born, yet these LRDS glow with the intensity of dwarf galaxies, their ultraviolet light rivaling modern systems. Glimpse data, updated October 2025, reveal candidates at redshift 16 with radii of 650 light-years, far larger than the tiny building blocks we expected. This early growth paradox challenges standard cosmology, which posits small clumps merging slowly. Instead, these galaxies suggest rapid star formation, possibly fueled by massive stars or minimal dust, as their blue UV slopes indicate pristine, young stellar factories. The number density, more LRDS per volume than predicted, hints at a universe that hit the ground running, forming stars with reckless abandon. Emotionally, this paradox is a roller coaster. Excitement at discovery, frustration at unanswered questions, and awe at a universe that defies our rules. It's a global enigma, sparking debates from observatories in Australia to universities in India. Were these galaxies super efficient at turning gas into stars? Did dark matter clumps form earlier, acting as cosmic cradles? The human connection is visceral. Think of the times you've grown faster than expected, defying odds in your own life. Recent analyses suggest some LRDS may evolve into the massive galaxies we see today, seeds of the Milky Way's ancestors. This story unites us in curiosity, urging us to question and explore. If these red dots intrigue you, hit like and share. Let's get the world buzzing about this mystery. Comment: what do you think powered these precocious galaxies? In a crimson speck, a monster hides. Kuiper's LRDZ9, at redshift 9.288, shines from 500 million years post-Big Bang, harboring a black hole of 38 million solar masses, possibly up to 300 million, as confirmed in October 2025. Detected by JWST's NIRS-PEC, its spectrum reveals a broad hydrogen beta line and narrow oxygen lines, hallmarks of an active galactic nucleus, AGN. Gas swirls at 2,200 kilometers per second, a Doppler broadened signature of a gravitational titan dominating a galaxy with just a billion solar masses in stars. This is no ordinary black hole. It's a cosmic anomaly, challenging growth models. How did it grow so massive so fast? Standard models suggest black holes form from dying stars, starting at tens to hundreds of solar masses, limited by the Eddington rate, a cosmic speed limit where radiation pushes back infalling gas. To reach 38 million solar masses in 500 million years from a light seed requires super Eddington accretion or mergers, defying norms. The heavy seed hypothesis, gaining traction in 2025, posits direct collapse of massive gas clouds, birthing black holes of 1 million solar masses. The Infinity Galaxy, discovered July 2025 in Cosmos Web, supports this. A collision of two disk galaxies forms a third black hole of 1 million solar masses in the debris, confirmed by Chandra X-ray and VLA radio data. This discovery evokes awe and urgency, a universe where giants rose swiftly, shaping their galaxies. LRDZ9's dominance suggests gas funneled to the black hole, not stars, a cosmic trade-off mirroring human sacrifices for growth. Compared to GNZ11, Z equals 10.6, star-powered, LRDZ9's AGN-driven glow highlights early diversity. Future observations, higher resolution spectra, X-ray hunts, promise more clues. Emotionally, it's a saga of mystery and ambition, uniting global dreamers. Like, share, comment. What's next for these cosmic titans?